Alright, here's a little video on linear relationships. We're going to start with slope. Alright, you have a table. You can find the slope of the line by using your slope formula, which is y2 minus y1 over x2 minus x1. Or you can just see what the change in the y is and put it over the change in the x. Right? So if we see the y is your vertical distance, because up and down is always your y-axis, horizontal will be your x. So 9 to 18 changed by 9, and 12 to 24 changed by 12. You would get 9 over 12, simplify it by dividing both by 3, and you get 3/4. Alright, same thing over here. This is the same information, just in a graph form. You would do the same thing. From any two dots, you can just rise and run. So if we choose, for example, these two dots, you can see what the rise is from 12 to 24. The rise, from 9 to 18, the rise is 9. 12 to 24, the rise is 12. And we get the same answer as above. Even if you use bigger numbers, as long as you simplify, you're going to get the same answer. So rise over run. Rise means up or down. Run is always right to left, or left to right. Alright, let's go to some examples here. So if we want to find the rise over the run here, right, we can see how much it went up from 60 to 90. We know it's 30. And from 2 to 3, it went up by 1. So 30 over 1, which equals 30. Now you can also use the formula, right? 90 minus 60 over 3 minus 2, and you get the same answer. Or you can count what the rise and the run is and simplify it, and you get the same answer. So here's another word problem example here. So from the table, from the graph, we have information, right? We have 5 minutes relates here to negative 400, and we have another dot over here that's 10 minutes, and it's already at negative 800. So to find the slope, you just subtract the y minus the y, which is what they did up here, over the x minus the x at the bottom. That gives you negative 400 on top, 5 on bottom, and then your answer is negative 80. Make sure you simplify at the end to get the slope. Alright, let's move it along here. These should be more test style questions. Right, so first of all, a proportional relationship, right, means it is linear, right? It has to be a linear relationship, but it's important that it starts at 0, 0. If it doesn't start at 0, 0, it's not considered a proportional. So just make sure it goes through 0, 0 before you answer yes or no to being proportional. And now to find the slope, just look at the change in the y and the change in the x. So from 5 to 10, it went up by 5, and from 2 to 4, it went up by 2. So 5 over 2 is your slope, and that's it. Same thing on this side, but here from 0 to negative 3, it went down by 3. So we put negative because it went down. And then from 0 to 2 on the x, it went up by 2. So this slope is negative 3 over 2. Still proportional. Because it goes to the origin. Alright, so let's just try to practice graphing it here. You have 6 kilometers of real world distance. So that is, real world is your y-axis, so that would be related to that spot. and then the x represents the map distance right over here. So every 1 centimeter of map distance is 6 kilometers of real world distance. So our x-axis, centimeters right here, is the 1. And now wherever those two values meet is where you put your dot. Now of course 0, 0 is where you start from, and you can draw your line. Now if you don't draw great lines, right, you can just always do more points, right, by using this proportional relationship. So if every 6 is 1, every 2 would be 12. So you can map 2, 12 here. And now you have 3 dots to go through. You can draw a better line. Alright, same thing here. 3 ounces of nuts, 2 ounces of dried fruit. So dried fruit is your x, because it's on the x-axis. And 3 ounces of nuts is your y value, because it's on the y-axis. So you just graph 2, 3, mark your 0, 0. And you can follow that same pattern going up. Every 3 is 2, every 3 is 2, because your slope is 3 over 2. And we graphed it. Alright, so let's just look at these two and answer these questions simply. It goes through 0, 0, and it's a proportional relationship. 2, 1, 4, 2. Let's do one more. 6, 3. So it's always going up by 1 on the y's whenever it goes up 2 on the x's. That's a proportional relationship. So it is a proportional relationship because it is a straight line that does go through the origin. Origin is 0, 0. Remember, that's necessary to be proportional. Now this one is not a proportional relationship because it doesn't go through 0, 0. So we put does not. Alright, let's keep it moving here. So here, straight line that goes through 0, 0. So it does represent a proportional relationship. Let's look for that answer. Check that box. And it does pass through the origin, so we check pass through the origin. Pretty simple. And now part B is what is the slope of the graph. So to do that, you have to mark a couple dots. Two, 88 is one dot I chose here. You can mark any dot really, like 1, 44 right there. And now if your x is 1, you're looking at the slope really, but it's not in fraction form yet. So 44 over 1 would be the slope. But for the sake of work, let's just see the change, right? You can subtract 88 minus 44, which is finding you the change in the y, and 2 minus 1 on the bottom, see the change in the x, and it gives you 44 over 1. Same answer we got. So 44 over 1 equals 44. And now what does that even mean? Right? That means that for every 1 what? 1 week. For every 1 week, it's $44 of savings. So you check that box. Alright, we're almost at the end here. So now, which of the following of the functions are linear? To be linear, it has to have a common difference. What does that mean? That just means a plus or minus pattern. So if from one value to the other, you have the same pattern, as long as it's a plus or a minus pattern, then it is linear. Make sense? So from 3 to 6, it's going up by 3. From 6 to 11, it's going up by 5. Already we know that cannot be linear. Because if it's double the amount, it would be 6, not 5. So let's keep it going here. From 20 to 18.5 is going down by 1.5. From 18.5 to 17, down by 1.5. From 17 to 15.5, down by 1.5. So you see, once you see that you have the same pattern, then you know it's going to be a linear relationship. Function B is linear. Alright, now let's get to writing a full equation of a line. To write an equation, you need two things. You need the slope, which is m in this situation, and your y-intercept, which is b. Once you have those two, you have the full equation, because you just replace it in those spots. Right, so let's find the slope by seeing the change in the y here, and the change in the x. And make sure you keep your order. If you start with the 34 here, you have to start with the x value for that 34 on the bottom. So now we get 25 over 5, which equals 5. That's our slope. So now right now we have y equals 5x plus b. Now to find that b value, that new y-intercept, all you have to do is plug in one of these x's and y's that are together wherever you see the x and the y, like this, and you just solve it and you'll have your new y-intercept. So 5 times 2 is 10. To get b by itself, you need to subtract 10 from both sides. That gives you b equals -1, because 9 minus 10 is -1. So now we have the full equation. The slope was 5, so that has to be the number that touches x, because your slope always touches x, like this. And the y-intercept is the number with no variable on it, that is -1. Alright, now if they give you on the table a x value that's 0, then the number next to it will be your y-intercept. But they didn't give us a 0, so we had to solve for it. Alright, let's try this one here. 23 minus 5 is 18. 7 minus 1 is 6. If you simplify that, it gives you a slope 3. So now we have y equals 3x plus b. And we plug in our 5 and our 1 from the first point in the table and solve it. So first we do 3 times 1, which gives you 3. And now subtract the 3 from both sides, so you get b by itself. And the answer will be on the other side, +2. So let's write the full equation now. Y equals 3x plus 2. Make sure the slope touches x and the 2 does not. Alright, this is another one here where, you can practice it on your own. Let's keep it moving here, because this is a long lesson. So on both of these, they're just asking which one's a function, right? On a graph, you can easily test it out by doing vertical lines. If you do a vertical line or vertical lines all over the graph, right, it should only touch one time the graph. It's a function. So here, it's a closed figure, circle, so it touches twice. Once it touches twice, it is not a function. So again, here, if I draw a straight line, it touches twice. This is not a function. Here, touches twice, is not a function. So we know the answer is this last one. Why? Because if I draw a straight line, it doesn't touch either one. Okay? So the concept is simple. If you have a V or a U that opens up, that is still, yes, a function. But once you turn it sideways like this, it is not a function anymore. Clear? Same thing when you have dots. If you have an open dot like this, and right below it you have a colored dot, right? It goes through that because it's not colored in. This is still a yes, a function. But once that's colored in, turns it to a no because they touch at the same spot. Same concept on a table, but you don't have to look for anything but the X column. So here, just look at the X column. And to be a function, the X cannot repeat. If the X repeats, it's not a function. Because if you plug in a value into an equation, you should get the same answer every time if you're plugging in the same value to be a function. So here we see the 5 repeats, not a function. Here the 2 repeats, not a function. On the second one, nothing, no X value repeats. This one is a function. And this last one is not because the 0 value repeats. Pretty simple. Now let's move on to second to last page. So same concept here that we were doing before, but now it's a word problem. The slope is the same process, it's just representing a situation in the graph. So you can easily mark some points yourself and find out what the slope is. So from here, which is 15, 5,15, to the point above it, which is 10,25, we can see that the y changes by 10 and the x changes by 5, more or less. So the slope should be 2. So already we know we can't answer anything that doesn't say slope is 2, so B is not going to be the answer. Now here, the y-intercept is 2.1. We know that's wrong because the y-intercept is not the same value as the slope. It touches right here, which is close to the number 5. Letter D says the y-intercept is 5. So this is correct, and the first one's correct. So let's see which one's worded correctly. The slope. This means that each kilometer costs $2.10. That is correct. Let's see why the last one is wrong. This means that the ride lasts 5 kilometers. That's not true because this line goes on forever. So the one that's true is this one. Simple common sense, but make sure you read it because a lot of these answers look the same. Alright, so over here you have 0,10 that you can mark. That's your y-intercept. Notice it's an x that's a 0 because your y-intercept has to have an x that's a 0. Now if you mark another dot, you can gauge what the slope should be. So from here to that next dot, it's going to be up 10 and right 2. So the slope should be about 5. So slope can be 15. Slope is 4.5. That's close enough because we didn't choose perfect dots. The y-intercept is 15. That's true because we can see that the graph goes through the y-axis on 15. This one's wrong because it says the y-intercept is 4.5, and it's clearly not because the y-axis is here. It does not touch on 4.5. So now between the two that we have to see which one's worded correctly. The y-intercept is always your starting point. What's another word for start? Initial, beginning. So this one says initial is 15. That is correct. Alright, last page coming up. And this is an easy question. So same process here. These are x values, which are part of your domain. Domain means all possible x values. And of course, range is the opposite. Range means all possible y values. So it's important to know that these arrows represent points, right? If 1 has an arrow to 42, that means 1 point is 1, 42, right? So it's important to know when it's an x that's repeating. So let me write the next 2 that show up here. 2 has 2 arrows coming from it. 2, 21, and 2 also goes to 42. So already this x value repeats, so it is not a function. Right? So you gotta make sure when they give you a map, because this is called a map, you make sure that on the left side, which is your x column, there's no double arrow situations, only one arrow, one line coming from each x value. The y values could repeat, that's not a problem. The ones that can't repeat are the x values. So this one, yes, is a function because the x's don't repeat. This one is not a function because the x's do repeat right here. So let's answer these questions. Not a function here because it repeats. And domain are these x values 1, 2, 5, and 11. So we check that box. Range is these y values that you have here, which is 5, 9, 21, and 42. So we check the range that's correct. Same process over here. Look at your x values to select the domain range. Don't mess those up. X values are domain 0, 2, 5, 9. This is a function because the x values don't repeat, only one unit in the domain. And the range is these 3 numbers right here. So check the range. Alright, hopefully this helps. Another video coming soon.